Many of you are struggling to work with big data, which comes in a variety of forms. One type of big data is spatiotemporal event information. For example, here, we're drawing 1 billion financial transactions across the US. The problem with this kind of data is that to visualize it, you'd have to wait, and wait, and wait, and see if it ever actually stops drawing. The only way to truly visualize 1 billion records at once is to aggregate it into a form that you can understand. So how did we create this aggregated layer of 1 billion records? We've been working hard to enhance ArcGIS with capabilities for batch analysis on these kinds of huge data sets. GeoAnalytics will be a new extension that lets you run spatial analysis as distributed processes across a cluster of machines. GeoAnalytics tools are designed to help you understand your data. You'll be able to find hotspots, run buffers, and do aggregations so that you can reduce and summarize your data in ways that let you explore patterns. GeoAnalytics tools can run on a cluster of machines, so you can run bigger jobs than ever before. In this case, we aggregated 1 billion financial records by the nearly 74,000 census tracts across the United States. Now, seeing patterns is a good first step to understanding your data. But often in these mountains of information, what you're actually looking for is the needle in the haystack, the activity that differs from the normal pattern. And in the case of financial data, often what we're looking for is waste, fraud, and abuse. So what does financial fraud look like? Let's see an example of how money laundering actually plays out on the ground. One technique used by criminals to move large sums of money around is spreading it out over multiple cash transfers. One or a few people will quickly visit several financial institutions and send transfers that are below the official reporting threshold. Many of you have domain expertise like this. You understand some of the ways that illicit activity happens, but how do you query for that? How do you teach a system to detect that? In the case of this fraudulent behavior, you'd have to consider distance, time, the amount of money, the recipients, and then you have to do it all 1 billion times. GeoAnalytics includes tools to let you ask these kinds of space-time questions in ways that you've never been able to before. For example, the Join Features tool lets you find associations between features based on attributes, based on spatial relationships, and based on temporal relationships, all at the same time. This is multi-dimensional relationship analysis, and it's never been possible before at this level of space-time detail. We used Join Features in this way to mine 1 billion financial transactions for this kind of fraudulent behavior. So let's see how that happens. GeoAnalytics tools work with your data. You can use them with traditional geospatial formats, or you can attach your big data to ArcGIS as file shares. Now, to find this fraudulent activity, we focused on the origin locations of these transfers, like those that you're seeing here in this example. And we joined these transactions against themselves. So for every single transaction, we asked how many others took place within a kilometer and an hour of it that were going to the same recipient. And GeoAnalytics tools let you calculate statistics on any of your input fields, so we can total the amount of money involved and use it to refine the results. Using a cluster of 140 machines, we ran this billion to billion join in 48 minutes. 48 minutes to burn down that haystack and find all the potential needles within it. And what we're left with are bursts of transactions in the same small area that all went to the same recipient somewhere else. And we can use the amount of money involved across the number of transfers to isolate and focus on the most suspicious behavior. Imagine running this kind of analysis as part of a daily practice to find fraudulent activity in your own domain and use it to prioritize for further investigation. The GeoAnalytics tools will bring the power of distributed processing to your vector big data and open up entirely new ways for you to mine information across space, time, and signal. And we're looking forward to seeing how you apply these tools to answer the questions that you never thought you could solve. Thank you. Jack?
Thank you, Suzanne. That's great. Now, I suppose you're beginning to think about the relationship between insight, which you just saw, and the big data world. This is an amazing time because these are designed to work together. So the notion of being able to do very, very big data analytics, for example, all the forest plots for the entire Forest Service for the last 50 years, together with an intuitive exploratory tool to be able to look at it, query it, and come up with some new ideas, that's all designed to work together, which is pretty neat for me.